In episode 9, you deployed a bare pod, deleted it, and watched it stay gone. Nothing was watching over it. This episode, we fixed that with the object you'll actually use for almost everything, the deployment. A deployment is a Kubernetes object that owns a set of identical pods and continuously makes sure the number running matches what you asked for. This is the controller manager's job from episode 8, made concrete. You declare 3 replicas of this, and Kubernetes enforces that number forever, not just at creation time. Here's a deployment in YAML. It looks like the pod spec from episode 9, but wrapped. A replica's field set to 3, a selector that tells the deployment which pods belong to it by label, and a pod template describing exactly what each of those 3 pods should look like. kubectl apply-f deployment.yaml creates it. kubectl get deployments shows the deployment itself, desired count versus current count. kubectl get pods shows all 3 pods it created underneath, each with a name based on the deployment's name plus a random suffix. Now let's do the thing episode 9's bare pod couldn't survive. kubectl delete pod and one of those 3 pod names. Watch kubectl get pods immediately afterward, and there are 3 again. A new one appeared in seconds. You deleted a pod, and the deployment's controller noticed the count had dropped to 2 and corrected it back to 3 automatically without you doing anything else. Scaling up or down is just as direct. kubectl scale deployment, your deployment's name, -- replicas equals 5. The desired state changes, and the controller drives the actual state to match. 2 new pods appear, with 0 new YAML. Under the hood, a deployment doesn't manage pods directly. It manages a replica set, which is the object actually responsible for keeping the pod count correct. You'll rarely touch a replica set by hand. The deployment creates and manages it for you. The reason a deployment exists as a separate layer on top is the next feature, rolling updates. Change the image in your deployment's YAML to a new version and reapply it, and Kubernetes doesn't just kill all 3 old pods and start 3 new ones. That would mean a gap with 0 pods running. Instead, it performs a rolling update, bringing up new pods gradually while gradually retiring old ones, so your application keeps serving traffic the entire time. kubectl rollout status deployment, your deployment's name, watches that rollout happen in real time. And if the new version turns out to be broken, kubectl rollout undo deployment rolls the whole thing back to the previous version, the same gradual way. Let's recap. A deployment keeps a declared number of pods running, replacing any that disappear. That's episode 9's gap, closed. kubectl scale changes that number on demand. And rolling updates mean new versions ship without downtime, with an instant undo if something goes wrong. We've been managing one deployment in isolation. In episode 11, we cover services, how traffic actually finds the right pods when there might be 5 of them, each with a different, constantly changing IP address. Subscribe so you don't miss it. See you then.